Hi students, welcome to MI Academy, and today in this video we are going to start the grade 10 chapter 3, of the science, structure of matter. If you have not still subscribed to MI Academy, then click the subscribe button, and give us a support, and then turn on the notification bell icon, to all, so that you can watch my upcoming videos without missing. Then first let's see what are the topics that we are going to study in this chapter. So first we will be looking at what is matter, then in that we will see how can we classify matter. Then we will see what are atoms and how it is formed. Then next we will learn about a model called Planetary Model. Through this model you will get a more clear idea about the structure of atom. Then we have the topic electronic configurations. Here you will learn how to fill electrons in respective energy levels. Then we will be studying about the modern periodic table where all the elements are listed in a proper manner according to the atomic number. Then we will discuss about isotopes and we will look at several examples of isotopes. Then we will see some of the patterns seen in the periodic table such as first ionization energy, electronegativity. Then we will look at metals, nonmetals, metalloids, and we will discuss some of the examples of them. Then at last we will study how to write the chemical formulas of the compounds. If you look around you in your environment, there are living things and non-living things. And these non-living things can be divided into two types, one is matter, the other one is energy. Anything that has a mass and occupies space is called matter. Whereas anything that doesn't have a mass and that does not occupy space are known as energy. For matter we can say a ball, a rock, water, air, all these come under matter. Whereas for energy, heat energy, light energy, sound energy, likewise you can go on giving examples for energy. And matter can be classified based on its property. Mainly in two different ways, that is based on its physical property, and according to the chemical composition. When we say physical nature, if you take an object, say a box, you can touch it and feel it. It will be hard or it can be brittle, it can be very strong. And it can exist in different states, the three different states of matter, the solid, liquid, and gas. For example, if we consider the compound water, it can exist in all three states of matter. In the solid form we call it the ice, and in the liquid form it is water. And in the vapor form we call it the water vapor or steam. Then based on chemical nature of matter, there are two main types, one is the pure substances, the other one is the mixtures. When we say pure substances, any substance that has a definite composition and is made up of only one type of substance is known as a pure substance. Then we divide it into two, the elements and compounds. So when we talk about elements, they are the pure substances which have definite properties and they cannot be divided into smaller independent components with definite properties by physical or chemical methods. If we take iron as an example, you have a piece of iron rod. By applying a physical change or a chemical change, you can't convert it into a different substance that has specific properties. If you divide it, it's still going to be iron, then it's known as an element. But when these elements combine in a fixed ratio, they form compounds. Compounds also have definite property and they also cannot be broken down into individual components by physical methods. Example, if we take oxygen combining with hydrogen, we get water. The properties of water are different from hydrogen and oxygen. Similarly, carbon has certain properties, oxygen has certain properties, and carbon dioxide has properties of its own. So all these, the elements and compounds, are pure substances with definite characteristics or properties. Then if two or more pure substances combine together, they form mixtures. Mixtures can be divided into two types, based on how their composition is distributed throughout the mixture. So we have homogeneous mixtures. Homo means same. If the composition of a mixture is uniform, then it is known as a homogeneous mixture. For example, salt solution. The salt exists as crystals and water is a clear liquid. If you mix them together, you get the salt solution. Once it's mixed completely, you cannot differentiate salt from water. And throughout the solution it is salt. Likewise is the sugar solution or a fruit juice. On the other hand, we have heterogeneous mixtures. Hetero means different. Here the composition is not uniform throughout the solution. One example is sand mixed with rice. You can identify the rice grains from the sand particles in the mixture. So I hope students you all have a very good understanding about the different types of matter according to their chemical composition, but all these substances have one common property: they are all made up of the same building unit. That is the smallest unit that makes up matter. It is what is called as atoms. So now we will look at what atoms are and their structure. Atomic atoms, as I said, are the building units of matter. And these atoms can chemically combine and they have specific properties. So to know about atoms we should first know what atoms are made up of. They are made up of subatomic particles, and there are three types of subatomic particles: protons. Protons are positively charged subatomic particles. Then we have the second type, neutrons. This does not have charge. And the third type is electrons, and this has negative charge. There are equal number of protons and electrons in an atom. So the number of positive charges are equal to negative charges. Therefore atoms are electrically neutral. Now we will see how the subatomic particles are arranged in an atom. So to know that we discuss model of an atom. Now scientists got the knowledge about atoms and subatomic particles throughout the years, and they wanted to explain how these atoms get their special definite properties. So in order to do that, there are different scientists who propose different structures or models for atom, but only a few of those structures were accepted models. The first accepted model of atoms is the nuclear model, and this model was put forward by a scientist called Ernest Rutherford. According to the nuclear model put forward by Ernest Rutherford in 1911, there is a very small area called nucleus at the center of the atom. If the atom is a football ground, nucleus is a small volume, even smaller than a chickpea at its center. From this example, it is clear that the nucleus of an atom is very small relative to an atom. Protons and neutrons are accumulated in the nucleus. The nucleus is positively charged. Electrons revolve around the nucleus. The number of electrons in an atom is equal to the number of protons. However, the protons and electrons are oppositely charged, and therefore, the atom is electrically neutral. The planetary model of the atom was introduced by Ernest Rutherford. Electrons move around the nucleus in which the positive charge of the atom is concentrated. This is similar to the solar system where the planets revolve around the sun. Then people had questions saying that, okay, now in this the positively charged protons are in the center and the negatively charged electrons are moving around this nucleus. Normally the positive and negative charges attract each other. In that case these electrons should get attracted to the nucleus and come and fall on it. So Niels Bohr, who further elaborated the Rutherford's model, stated that the electrons move in definite paths or shells around the positively charged nucleus. And electrons revolve very fast around the nucleus. So now if you look at this diagram, you can see this tiny part is the nucleus of the atom, and inside the nucleus there are two subatomic particles, the protons and the neutrons. Here you can see in this diagram these are electrons which are moving around the nucleus in definite paths or shells. The shells in which the electrons revolve around the nucleus are assigned either numbers 1, 2, 3, 4, or letters K, L, M, N, respectively, starting from the nearest to the nucleus. The shells are also known as energy levels. Each energy level has a specific energy. When moving away from the nucleus, this energy increases. In an atom, there is a maximum number of electrons in each energy level. The below table gives the total number of electrons in the first 4 energy levels nearest to the nucleus. And all these energy levels can contain only a fixed number of electrons. When you start from the energy level closest to the nucleus, as you go out the number of maximum electrons will increase. So in the first level, that is the K shell, there can be only 2 electrons maximum. There can be 1 or 2 electrons. But in the second shell, that is the L shell, there can be a maximum of 8 electrons. Up to 8. If we look at the third shell, the M shell, there can be a maximum of 18 electrons, but we consider it as 8. This is a different concept, you will study in your upper grades. For now you no need to know them, just follow M shell as 8 electrons. And in the fourth shell, that is the N shell, there are 32 electrons. As you can see here in the diagram, the nucleus is shown in the center and all the energy levels are shown around it. If you look at these energy levels carefully, as we discussed before, you can see the distance between energy levels K and L is more than the distance between the L and M shell. And the M and N shell has a very small distance between it. The reason you already know. Because the energy of shells increase from K to N, but the gap decreases. There are some of the important terms or unique properties for each of the elements. Now we will see what atomic number is. The atomic number is the number of protons in an atom of the element. For example, there are 11 protons in the nucleus of a sodium atom. Therefore, the atomic number of sodium is 11. The number of protons in every atom of the same element is equal. The number of protons in different elements is different. Therefore, the atomic numbers of two atoms of different elements will never be the same. Hence, the atomic number of an element is a unique characteristic of that element. The atomic number of an element is symbolized by Z. In a neutral atom, the number of protons is equal to the number of electrons in it, so that the atomic number of an element is equal to the number of electrons in an atom of that element. However, when chemical reactions take place, electrons may be either lost from or gained by atoms. Such charged atoms are called ions. The number of electrons in an ion may be less or more than the number of protons. But, since the number of protons in an ion formed by a particular atom does not change, its atomic number remains unchanged. The mass of protons and neutrons is nearly equal. Approximately, the mass of an electron is 1,840 times smaller than the mass of a proton. So comparing to the mass of protons and neutrons in an atom, the mass of electrons is very small. Therefore, the mass of an atom depends only on the mass of protons and neutrons. So the sum of the number of protons and neutrons in the nucleus of an atom is called the mass number. Symbol A signifies the mass number of an element. For example, the atomic number of sodium is 11. Hence, a sodium atom contains 11 protons. If it contains 12 neutrons, the mass number of the sodium atom is 11 plus 12, 23. There is a standard way of writing the atomic number and mass number of an element, as shown in the figure below. On the left-hand side of the symbol of the relevant element, the atomic number is written at the bottom and the mass number at the top. The difference between the mass number and the atomic number gives the number of neutrons in the atom. Now we will see how we can arrange these electrons into different energy levels. So the arrangement of electrons into energy levels of an atom is known as the electronic configuration. So representing how electrons are filled in the respective energy levels is called electronic configuration. So when we arrange electrons into atoms, they fill up the shells with less energy first and then they go into the higher energy shells. That is where we have the electronic configuration and the arrangement of electrons. So in order to fill, we have to allocate electrons as 2 electrons for shell K, 8 for shell L, 8 for shell M, remember not 18. 32 for shell N. Now we will look at the first 20 elements and how electrons are arranged into energy levels. It starts from hydrogen, the symbol is given and you can see the atomic number starts from 1 and it goes up to 20. Students, you will have to memorize the order of these first 20 elements in order. This is given in your textbook, you can refer it. So we have the first element, hydrogen. It has only 1 electron, because the atomic number is 1. So when we write the electronic configuration, the electron goes into the first shell, K. Then it is helium, it has 2 electrons. So the 2 electrons can go into the first energy level, K shell. The third element is lithium, Li, and the atomic number is 3, therefore the number of electrons are 3. The first shell will have only 2 electrons, then the next electron will have to go into the second shell. Then the electronic configuration is 2. 1. Beryllium. Be. Atomic number 4. So the first shell will have 2 electrons. The second shell will have 2 electrons. Then we have boron. Atomic number 5. First shell 2 electrons and the second shell has 3 electrons. Now you can see when the atomic number increases, the number of electrons in the second shell is increasing 1 by 1. So next is carbon. Atomic number 6. So the first shell will have 2 electrons. The second shell will have 4 electrons. Then nitrogen. Atomic number 7. So 2 and 5. Then the next element is oxygen. Atomic number 8. So 2 electrons in the first shell, 6 electrons in the second shell. Fluorine. Atomic number 9. 2 electrons in the first shell and 7 electrons in the second shell. And neon. Here you can see atomic number 10. 2 electrons in the first shell and 8 electrons in the second shell. Here the next element is sodium. Sodium is So2 in the first shell only, 8 in the second shell, the next one electron goes into the third shell. The next one is magnesium, atomic number 12. Now you know to write the configuration. 282, then aluminium 13. 283, silicon 14. 284, then phosphorus 15. 285, sulfur 16. 286, chlorine 17. 287, argon 18. 28 and 8, potassium 19. 2881, calcium 20. 2882. So I hope you have understood up to now, and we have come to the end of our video. We will study from the periodic table topic in our next video. So please give a support to us by subscribing to MI Academy, and also please like my videos, and add up your questions and doubts in the comments. I will try to reply them as soon as possible. Share the videos with your friends, and help them to learn quickly and easily.